integrate x squared over the square root of 4 minus x squared dx. Now, if you don't already see it, this is an integral that you could solve using trig substitution, because in your denominator you have the form of square root of a squared minus x squared. And you know, when you see this form, you would use x is equal to a sine theta as your substitution. So let's do that here. In our case, our a squared is equal to 4, so that means our a is going to be equal to 2. So x is going to be 2 sine theta. My d theta is just going to be the derivative of my x, so this is going to be equal to 2 cosine theta d theta. Now that I have all my definitions, I could substitute everything into my integral and rewrite it in terms of theta. So this is equal to the integral of x squared. In my case, it's going to be 2 sine theta squared, so 4 sine squared theta, all over the square root of 4 minus x squared. X squared again is 2 sine theta squared, so 4 sine squared theta. And then my dx, I said, is 2 cosine theta d theta. So I'm going to be multiplying that by that as well. And now that's everything rewritten in terms of theta. Now let's clean everything up by simplifying and also dealing with our constants. So I see that I have a constant 4 and 2 that I could pull out of the integral. And so now I have outside of the integral 8. And then my integral has sine squared theta in the numerator. And I'm also going to pull up that cosine up here. Cosine theta over the square root. Now, my square root over here can also be simplified using the identity that 1 minus sine squared theta is equal to cosine squared theta. The only difference here is that this is all multiplied by a factor of 4. So this means that my cosine in this case should also just be multiplied by a factor of 4. And now I know that my square root is the inside of my square root is 4 cosine squared theta and then d theta at the end. And now I could start simplifying things even more by getting rid of that square root so that I have, again, 8 is left outside, sine squared theta cosine theta over just 2 cosine theta d theta, reduced by that square root. Now that I have all of that, I could do some more simplifying. Those 2 cosines get rid of each other, and then I have that 1/2 that I could also pull out of the integral because it's just a constant, so that my 8 is reduced to a 4, and all I have left to integrate is sine squared theta d theta. Now to integrate this, I will be using the half angle identity, so that I have 4 square root of, 1 minus cosine 2 theta over 2. I'm going to write this identity on the side here just in case you haven't seen it before. So sine squared theta using the half angle identity, it's equal to 1 minus cosine 2 theta over 2. Keep this in your trig toolbox because it will come in handy whenever you deal with these kind of integrations. So with that, I could even take out some more constants out. So this is all divided by 2, so I could pull that out. And now I have 2, that 1/2 reduces that 4 to 2, the integral of 1 minus cosine 2 theta d theta. Now integrating this is much easier, so this goes to 2, that 1 integrated is theta with respect to theta, minus the integral of cosine 2 theta is going to be sine 2 theta divided by 2, plus an arbitrary constant c because this is an indefinite integral. And now I will be distributing that 2 in, and that 2 gets rid of this 2 over here, so that I have sine 2 theta plus c. Alright, now I'm going to start rewriting everything in terms of x, but first I have this sine 2 theta, which is an issue here, because the angle is 2 theta, which is a different angle than what I was originally working with, which was theta. So I need to rewrite this in terms of theta. So I'll be using the rule that, one more identity that we're going to be using, is that sine 2 theta is equal to sorry, is equal to 2 sine theta cosine theta. So lots of trig identities, but they're manageable. So that 2 theta doesn't change, minus 2 sine theta cosine theta plus c. Now I'm going to be finding what my sine theta is and my cosine theta is and what my theta is in terms of x. So going back up here, I've already defined that x is equal to 2 sine theta, and I'm going to be using that back here. Let me rewrite it. So x is equal to 2 sine theta, and now isolating that sine theta, x over 2 is equal to sine theta. Okay, now I found one component. To find theta, I will be doing the inverse of sine, so that I have arc sine x over 2 is equal to theta. So that's another thing that I found. Now to find cosine theta, I will be constructing a triangle to find it using the Pythagorean theorem. So if I have my sine theta is equal to x over 2, and I know that sine theta is equal to the opposite over the hypotenuse, then I know that my opposite side over here is x, and my hypotenuse is 2, and my missing side here is just going to be 4, because 2 squared, minus x squared, right? And I know that my cosine theta is equal to the adjacent over the hypotenuse, so this is equal to 4 minus x squared over 2. And this is just using trig and what you know about trig in the first place. So now that I have everything, I could plug it all into my answer, my solution over here. So 2 theta, I said theta is equal to arc sine x over 2, so 2 arc sine x over 2 minus 2 times, what did I say sine was, x over 2, and then my cosine is equal to square root of 4 minus x squared all over 2 plus c. Cleaning things up, I'll get 2 arc sine x over 2 minus that 2 will cancel out, so I'm left with x times the square root of 4 minus x squared all over 2 plus c. And that's it.